Well, welcome back. I'm going to do one more example with our lead and indium reaction that we had before. So it's 3 Pb2 plus aqueous plus 2 In as a solid makes 2 In3 plus aqueous plus 3 Pb as a solid. Still plus 0.22 volts on E0 for the cell, and it's a 6-electron process. But now I'm going to push you just a little bit, and we're going to solve with the Nernst equation, but we're not solving for E cell. So in this case, in this setup, if the concentration of Pb2 plus is equal to 0.100 molar and E cell is 0.300 volts, what is the concentration of In3 plus required to make those conditions? So in our Nernst equation, unfortunately now we're solving for one of the concentrations inside Q. And that gets a little dicey sometimes. So we're going to keep going with this. As I've told you before, be patient with the algebra. We have some manipulation to do here. Don't rush through it, because if you rush, that's when mistakes happen. So E cell is E0 for the cell minus 0.05916 volts over 6. That was our N value, right? Times the log of the quantity In3 plus squared over Pb cubed. And our job here is to find out what this concentration of In3 plus is. This is always the bummer one that you see on the homework, solving for one of those instead of just solving for E cell or E0, one or the other. So we got some manipulating to do. We need to get this log term by itself and then split it up so we get the indium concentration by itself. So we're going to do this in some steps. So the log of Q, which is the log of In3 plus squared over Pb 2 plus cubed. Getting that by itself, we divide and rearrange. So we're going to take E cell minus E0 for the cell. Okay, I'm kind of rearranging a couple steps at a time. I tell you what, I won't do that. Let's do this a little bit, baby steps at a time. So E cell minus E0 for the cell equals minus 0.05916 volts over 6 times the log, log, of indium squared over Pb cubed. So I moved E0 of the cell to the other side, it became negative. Now I'm going to get rid of the 0.05916 over 6. So E cell minus E0 for the cell divided by the quantity minus 0.05916 volts over 6. I just divided both sides by these numbers right here. Equals the log of indium squared over Pb2 plus cubed. Hang with me here. Don't want to lose you. Now we've done this before. The log of a fraction is equal to the log of the numerator minus the log of the denominator. So this equals the log of In3 plus squared minus the log of Pb2 plus cubed. Now we've got the indium in its own term. So we push everything to the other side. So E cell minus E0 for the cell over minus 0.05916 volts over 6. Bring this to the other side makes it positive. Plus the log of PB2 plus cubed equals the log of IN3 plus squared. Now we can start plugging in some numbers. We got our indium separated by itself. We know all of this other stuff. E cell, E0, all of this stuff. PB2 plus was 0.1 molar. So here we go. We're going to plug in our values. E cell, we said it was 0.3 volts. Minus E0 for the cell, which was plus 0.22 volts. Over the quantity minus 0.05916 volts divided by 6. Plus the log of 0.100 molar cubed. So keep your wits about you as you type this in. The numerator is not so bad. 0.3 minus 0.22 equals 0.08 divided by, open up set of parentheses, 0.05916, flip the sign negative, divided by 6, close your parentheses, equals. I have minus 0.225 for this term, plus 0.1 cubed I needed to push that in again. I needed an extra set of parentheses over there. So 0.3 minus 0.22 divided by the quantity minus 0.05916 divided by 6 equals one more time, 0.3 minus 0.22 divided by the quantity 0.05916, flip the sign, divided by 6, close parentheses, equals 8.11 minus 8.11 plus the quantity, so open a set of parentheses, 0.1 y to the x3 for third power, close your parentheses, hit your log, equals. Okay. Now for this one I get minus 11.11. So all of this stuff equals minus 11.11. That equals the log of IN3 plus quantity squared. So as we simplify this, IN3 plus squared equals the anti-log, or 10 to the power of minus 11.11. So minus 11.11, second function, log 7.76 times 10 to the minus 12. That's indium squared. So the concentration of IN3 plus that's necessary is equal to the square root of that number. So the square root of what's on my screen, 2.79 times 10 to the minus 6 molar. So at an indium concentration of 2.9 times 10 to the minus 2.79 times 10 to the minus 6 molar, and a lead concentration of 0.1 molar, E cell will be 0.3 volts. Now, this is the harder problem to deal with, especially on these calculators, right? Even me, who's an expert at these calculators, screwed up once. Okay. But you got to recognize when you do something wrong and not just blindly follow it through. I recognized that something was wrong because I couldn't cube a number that I needed to take the log of, so I needed extra parentheses. Don't be afraid to type these through twice. Even though it's a pain to type in, type it through twice and see if you get the same number twice. So at this concentration of indium, we'll have 0.3 molar, 0.3 volts of cell potential. Thank you.